right, guys, so you will be using the foldable, okay, to fill in. And our lesson today is on direct variation and inverse variation. So really, we're going to review direct variation first. Okay, so this will be the direct side over here. And this will be the inverse side. So one side will be direct, one side will be inverse. So when we did direct variation earlier in the last unit, we said direct variation was y equals to kx. Okay, how many people remember that? Y equals kx. Very good. And what was that common point when you graph direct variation? It passes through what? 0, 0, right, the origin. Okay, so if, and we're going to do some comparison here. So if y equals kx is direct, and direct is in the form of multiplication, because that's really k times x, what do you think the opposite of, well, what is the opposite of multiplication? Division. So this will just be y equals k divided by x. So once you know the other one is just the inverse of direct. So the opposite of multiplication is division. So instead of saying k times x, is k divided by x. So now we're just going to do a quick table. So let's just say I had the equation y equals to 2x. Okay, so say that's the equation I want to graph. And I'm going to put in some values for x. Now, I can definitely type this into the calculator, go to the table and fill it in, or I could just do it in my head and say 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 4 times 2 is 8. So I can definitely just do that or go to the table and copy. Okay, now I'm just going to do a sketch. We don't really need to do any numbers. So we know that direct variation looks like that. Okay. So right now we're just simply going back and reviewing what we know direct variation looks like. Okay. So let's continue on the direct side. So it says tell whether the equation or the table or the graph represents direct variation. So let's look at the first one. Y equals to 2x is not in the form of y equals to kx. So this is not direct variation. Actually, it has a different name that we've been talking about in this unit. What form is this in when it says y equals 2x plus 1? Slope-intercept form. So this is really slope-intercept form. Okay, let's look at number 2. Number 2 is in the form of y equals to kx, so I'm just going to put dv for direct variation. All right, now, when we did our last unit, we also looked at tables, and in order to tell if a table of numbers or a set of ordered pairs represents direct variation, you take the k equals y divided by x. That's how we test for direct variation. So here's your x value in the table. Here's your y value in the table. So when I test to see if it's a constant, that means if the number is not changing, when I divide, I'm going to do 8 divided by 2. That gives me 4. 16 divided by 4 gives me 4. 24 divided by 6 gives me 4. So what is my direct variation equation? Y equals to 4x. All right, who remembers doing that? Okay, very good, very good. All right, let's take a look at number 4. 5 divided by 1 is 5. 10 divided by 2 is what? 5. Is 15 divided by 4 5? No, so this is not direct variation. Okay, we recall that direct variation has to pass through 0, 0. This is passing through the origin. So yes, this is direct variation. Okay. Number 6 is not passing through the origin. That is not direct variation. All right, so that's just recalling what we already know. So now we're going to compare that to inverse variation. Okay. So now this is what I want you to do. On your calculators, go ahead and hit the y equals key, because you really do need to see what this looks like on your calculator. And you're going to type in y equals 2 divided by x. Okay, it looks totally different from a direct variation. Do you agree?
Yeah.
Right, so this particular one, which is opposite from direct variation, when you graph this, you should actually see 2 graphs. How many people saw 2 graphs? Right, so you should actually see 2 graphs, and that's the way it'll, for all direct variation, inverse, this is what your graphs will look like. Now, they don't necessarily always have to be in this quadrant and this quadrant, because this is the first and third. If you had put negative 2 divided by x, then it would have shifted to the second and fourth quadrants. Okay, so but they'll always be in opposite quadrants of one another. That's the point. Okay, this has a particular name since it is kind of special. The curve actually has a name. It's called hyperbola. So it actually has a nice name because you do have these 2 graphs in opposite quadrants. If you go to the table, I want you to go to your table. And if you go to the table where x is 0, what do you see? It says error. That means there will never be a point at the origin. Okay, so these 2 graphs will never touch 0, 0, which is definitely opposite from direct variation because direct variation always passes through 0, 0. Okay. So if we wanted to put some numbers in here, okay, let's just see what happens. Let's say we do 2, 4, and 6. So if I put 2, 4, and 6 in for x, well, 2 divided by 2 is what? 1. 2 divided by 4 would be 1/2. And 2 divided by 6 would be 1/3. Okay, so they'll actually end up being like decimal numbers. But you'll never have anything in here for 0. Now, since we know that to find k and put k over here is y divided by x, what do you think, or how do you think we'll find k for this? If this is division, what do you think this is going to be? It's going to be multiplication. It's just the opposite. Okay, so you are going to actually multiply x and y together to determine what the k value is, which is easier. Okay, just multiply the numbers because it doesn't matter if you multiply xy or yx because multiplication follows the commutative property. So let's take a look. This one now is asking, tell whether each relationship is inverse variation, direct variation, or neither. Okay, because it could be neither one. So let's look at number 7. First, let's test for inverse. Inverse means you multiply the x and y together. 10 times 10 is what? 100. 20 times 5, 25 times 4, 50 times 2. Looks like k equals 100. So now what we're going to do is write it as a inverse variation equation. So remember at the top right here, I said you take the k value and you divide it by x. That's what we're going to do. So I'm going to have y equals 100 divided by x. And there's your inverse variation equation. Okay. All right, let's look at number 8. So we got a test for both. So let's test for inverse first because we can just multiply them together. So on your calculators, go ahead and multiply 16 times 32, 12 times 24, 8 times 12. See if you are getting the same numbers every time. Yes or no? No. Okay, so if you're not getting the same numbers, now we're going to test for direct. So what is 32 over 16? 24 over 12. 12 over 8. Did you get the same number each time? Yes or no? What was your answer? No? Okay. So that's going to be neither. We'll just put in for neither. All right, take a look at number 9. Okay. Let's multiply. 20 times 4 is 80. 40 times 8, I already know that's not 80. So that's not inverse. Is it direct? 20 divided by 4 is 5. 40 divided by 8 is 5. 50 divided by 10. 100 divided by 20. So my direct variation equation is y equals to 5x because I was getting 5 each time. All right, last chart. If I multiply, what's 1 times 2? 2. 3 times 2, 6. So that's right away. It cannot be inverse. What if I do direct? 1 divided by 2 is 1/2. 2 divided by 3 is not 1/2. So this is what? Neither. Okay. Now, this can be tricky if you always think that you have to see all 4 quadrants. You may not always see all 4 quadrants. Here, they're only showing you quadrant 1. But they do show you that it is touching the origin. So this would be direct variation. And even though you don't see the other graph here, okay, this would be a inverse variation. And this is the way, guys, sometimes you might see it on a standardized test, your SOL test or an eCart. They may not show you all 4 quadrants. Okay, they may only show you the first quadrant. Okay, any questions on that? All right, so this is page 16 in your packet. Okay, because, and we're only going to concentrate on questions 1 through 12. So you might want to write that at the top of your paper, 1 through 12. All right, so it says here, suppose y varies inversely with x. So that means that's our new lesson today. I'm going to put that at the top. Y equals k divided by x. And k equals x times y, okay, because I don't know which one I will be, having to use. Looks like, because it says write an equation in inverse, which means I'll have to find k and then write it as an inverse variation equation. All right, so how do we find k again? We multiply x times y. So here's my x right here, here's my y. So what is 5 times 20? What was that? Okay, so 100. So what is my inverse variation equation? Y equals 100 divided by what? X. That's all you're being asked to do. Okay, so once you have your k, you take your k divided by x, obviously set it equal to y. So some of these might have fractions. It's okay. Just simply multiply on your calculator. 15 times 3/5. Your calculator can do that for you. Okay? All right, now, when you get down to, because I'm not going to work all of those, that's part of your classwork. So when you get down to the graphing part, okay, this is where you're going to need graph paper. So write graph paper. And you'll just punch this into the calculator and then choose some points that you're able to graph. Okay, that's all you're going to do. So this is just strictly being able to go to the table and graph the problem. Now, notice that this is not written with y equals. So what do you think you're going to have to do to this problem and this problem here? Solve for what? Solve for y first. So put a little note to yourself, solve for y. Okay, because you can't type this into the calculator this way. It has to be solve for y first. All right, move on to page 17. Same thing here, you're going to find k first. And really, all you're doing for 46, 47, and 48 is finding k. So put at the top, k equals x times y. That's all you're doing is multiplying x and y together. Here you're not. It says each pair of points is on the graph, and they do tell you it's inverse. Find the missing value. Okay, so this is what I would like for you guys to do. I want you to tell me what k is. How do you think you're going to find k? Multiply x times y. So if someone could multiply 5.4 times 3. So I'm going to do this problem right here. Is that 16.2? All right, so my k is 16.2. And this part here, guys, you might want to do on a separate sheet of paper. Okay, I'm doing it 49 right here, and it's going to take a little space. So if I know k is 16.2, I'm going to put, where I see k, I'm going to replace k with what? 16.2. So I'm going to have 16.2 equals, okay, do I know the value of x in the problem? Yes, 2, and I'm solving for y. So see how you just set that up? Okay, now I have a nice equation, 16.2 equals 2y. How do I solve that for y? Divide by what? 2. Very good. So now all I got to do now is divide both sides by 2. Who can give me the value of y? Yes. 8.1. Now I can check this because if y is 8.1, so that means when I multiply 8.1 times 2, I should still get 16.2. So check it out and see if that's correct. What is 8.1 times 2? It should be 16.2. Okay. All right. So for this page, you're going to actually stop at the table. This last table right here, this is where you stop. All right.